We just got done graphing a quadratic equation that was in vertex form. Most of the time we're given that function in standard form, so it's important for us to know how to go from one to the other. So if I want to rewrite this in standard form, here's my basic steps. First thing I'm going to do is I'm going to factor out any GCF between the first two values, so the x squared and the x value. So I'm going to start with f of x. I'm going to take the 2 out of these two terms. So that's going to leave me with x squared plus 10x, and I'm going to leave a plus blank, and then I have a plus 42, and I'm going to go ahead and put minus blank. Now we've done this before when we've completed the square, and when we did it before we had a plus blank and a plus blank, but that was on each side of the equal sign, and that worked because we were adding the same thing to different sides of the equal sign. So we're adding the same thing to each side. In this case, notice we're on the same side of the equal sign. So if I add something here, I have to subtract it out here in order for the net result to be 0. So that's my first step, is factor out the leading coefficient. I need to complete the square, which means I'm looking for b over 2 squared. b in this case is 10. 10 over 2 is 5. 5 squared is 25. So here I'm going to add 25. Now, before, we always had the exact same thing on both of these lines. In this case, that is not going to be the case because I've got a value out here. So in essence, I didn't add 25, I added 2 times 25, which is of course 50. So if I added 50 on the inside, I have to subtract the AC value. So this is my A and my new C, 2 times 25, I have to subtract that out here. And from here, I'm just going to clean it up a little bit. So f of x equals 2. This part in here is now x plus 5 quantity squared. And remember, the 5 came from the 10 divided by 2, which was 5 squared. So that's where that 5 came from. And it was positive because this is positive. And then plus 42 minus 50 gives me minus 8. So this is now my new vertex form of the original standard form equation. So now I could graph this by starting at -5, -8, knowing that it would be pointing upward, and I could find my intercepts and then graph the function. Here we're going to go through the entire process together. So again, we will start by doing some factorization of the first two terms. So I'm going to take out the GCF, which is -1. And we're always trying to get rid of whatever's in front of our first term, so our leading coefficient. That would give me x squared and plus 2x. Remember, because I'm dividing by a negative, that changes the sign. I'm going to leave a plus blank here. I have my plus 3, and then I have a minus blank, which is not quite the same blank on the inside. To find this value, I'm going to take 2 divided by 2 quantity squared. So 2 over 2 is 1. 1 squared is 1. So what I've done here is I've taken -1 times 1, so I've actually subtracted 1, which means out here I'm going to add 1. So I have to do the opposite of what I did. The function then turns into a -1 on the outside. This part now factors into a perfect square, which is x plus 1 quantity squared. 3 plus 1 is 4. And now I'm going to go through the process of graphing. So to graph, I would start with my -1, 4, which would of course be my vertex. It is pointing downward because of the negative, so I know it should end up with an x-intercept. Let's find the y-intercept first because it's easier. And I can plug it back into either form when I do that, but I'll go ahead and use my -1, 0 plus 1 quantity squared plus 4. 0 plus 1 is 1, 1 squared is 1, but then I take it times the -1, so that's -1 plus 4, which is 3. So 0, 3. And then of course I forgot to draw in my axis of symmetry, but it would go right through x equals -1, which is where my vertex was, which means I can reflect this to the opposite side. And now let's find 0 equals negative 1 times x plus 1 squared plus 4. I'll subtract the 4. I'll divide each side by negative 1. And then I'll take the square root of each side, which gives me plus or minus 2 equals x plus 1. To find those two values, I say x plus 1 equals 2, and x plus 1 equals negative 2. Subtract 1 from each side, I get x equals 1. And I could just go ahead and reflect that 2 spaces to the other side, but again, I should get the same thing here, x equals negative 3, and that is where that other point was. I'm not going to do any more points on that one because I already have 5 points, and I have a pretty good idea of what my parabola looks like. Go ahead and try this one on your own, so press pause, work through the entire question, including the graph, and then press play to check your work. To start off, I would take the 3 out of the first two terms, so x squared minus 2x plus blank, leave the plus 1, and leave the minus blank. Whatever's in the blank would be negative 2 over 2 squared, which is negative 1 squared, which is 1. So I'm adding 1 here. I'm not going to put a 1 here because I have 3 times 1, so I've added 3, which means out here I have to subtract 3. On the inside of my parentheses, I now have a perfect square, which is x minus 1, quantity squared. 1 minus 3 is negative 2. Now I can start graphing by looking at my vertex, which would be positive 1, negative 2. So 1, negative 2. Go ahead and draw in that axis of symmetry, which is that dotted line through the vertex. Then I would find my intercepts. So if I find my y-intercept, that's 3 times 0 minus 1 squared minus 2. 0 minus 1 is negative 1. If I square it, that's positive 1. So that's 3 times 1, or 3 minus 2, which makes it 1. So the y-intercept is 1. And I will reflect that over. On this question, I'm not going to bother with the x-intercepts because, as I can see, it's going to cross somewhere between 0 and 1, and somewhere between 1 and 2, which means I can find it, but it's just going to be a decimal anyway. So instead, I'm going to go ahead and say plug in 3 and see what happens. So f of 3 would be 3 times 3 minus 1 squared minus 2. 3 minus 1 is 2. 2 squared is 4. 3 times 4 is 12. 12 minus 2 is 10. So 3 comma 10. This one's very, very skinny because of that 3 on the outside. That makes it skinnier. To reflect that, I would go 2 to the other side of the axis of symmetry, and then I would connect the dots. Notice on this question, in addition to graphing it and writing it in vertex form, which this is my vertex form, I also want to find the domain and the range. So the domain is the set of all of the x values. So the x values, the domain, would be negative infinity to positive infinity because there's no restriction on any polynomial equation for the domain. For the range, however, as we can see, my very, very lowest point is negative 2 and everything else is above that. So my range would be close bracket on negative 2 up to positive infinity.